All right, tonight what we're going to be talking about is stoichiometry. And stoichiometry basically is the conversion between one reactant or product to figure out how much of another reactant or product you could make. So what we're going to do is we're going to use this thing called a BCA chart. And the BCA chart stands for before the reaction, how much it changes, so the C, the B, and after the reaction, so the A. So B stands for before, C stands for the change, so how much has it fluctuated because the reaction occurred, and A stands for how much you have left after the reaction. Since the BCA chart identifies how much, we are going to be only able to use moles in the BCA chart. That is key. So for every single thing, you need to be in moles in order to use that BCA chart. So there are processes that you have to do in order to use that BCA chart. The first one is that you're going to need to have a balanced equation. Okay, so we're going way back to the chemical reactions unit. So if I don't give you an equation, you're going to need to write out the equation, and then you're going to need to balance it based off the coefficients. Then what you're going to need to do is you're going to fill in your befores. How you do that is you always fill in 0 for your products. Why? Well, because before the reaction occurs, you've not produced any products because the reaction produces those products. And excess, you're going to write the word or the letters XS for excess if there's an excess of that reactant, meaning you have more than you actually need of that reactant. Then you need to calculate the change. So that was for the B, this is for the C. So what you're going to do is you're going to use those coefficients, you're going to set up a ratio, and that's called a mole ratio. So you're going to be comparing how many moles of one substance compared to how many moles of another substance. For every reactant, because they are consumed, you're going to subtract them. For every product, because they are going to be added, you are going to add them. Okay, because we're making products, they are going to be positive. Because reactants, you are going to be losing reactants, they are always going to be negative. And then the A for the after, okay, so for the BCA, the A for the after, you're going to write before plus the change, and then if it was excess, you're going to write excess. Okay, so I think it's easier to follow these steps once you actually have an equation. So for the s'mores lab that we did, or didn't do in class, but if you were making a s'more, what it states is that you have 2 graham crackers for every 1 marshmallow and 3 chocolate bars, and together they make 1 s'more. So for every statement of this, for every 2 moles of graham crackers, 1 mole of marshmallow, 3 moles of chocolate, there is 1 mole of s'more produced. Okay, so here is an example below of the BCA chart. What the BCA, remember, is before, change, and after. So what I'm going to always do is I'm going to fill out my befores initially from what I know. So reading it, how many moles of s'mores will be produced when 5 moles of Teddy Grahams reacts with excess chocolate and chocolate chips and marshmallows. So from this, I know that I have 5 moles of Teddy Grahams. So what I'm going to do is I'm going to do my before, and because it's in moles, I can keep it. So I'm going to write 5 moles. All right. I also know that I have an excess chocolate chips and marshmallows. So under marshmallows for my before, I'm going to write excess. For my chocolate chips, I'm going to write excess. Because I haven't produced any s'mores yet, I'm going to write 0, meaning I have 0 s'mores made. Now I'm going to base off my change. And to do change, you're going to be using all of these molar ratios that we've been practicing. So in this case, I know that I am going to use all of my graham crackers, and they're all going to go to they are all going to be used to make a s'more. So I know I'm going to be losing 5 moles. Okay, for these BCA charts, one of your things will always be losing everything. So what we're going to do is we're going to lose 5 moles. So I know I'm going to be losing 5 moles of graham crackers. Okay, but what I want to figure out is how many moles of s'mores can I produce. So I'm going to figure out X moles of s'mores. Well, I don't know that, but what I do know is that using these coefficients, for every 2 moles of gram, I can produce 1 s'more. So moles of gram has to go on top. Why? Because I started with moles of gram, and moles of grams is here, so they match up. And moles of s'mores has to go on the bottom. Why? Because moles of s'mores is on the bottom on the other side. So on this conversion on the right side, what I'm going to do is I'm going to use the coefficients of the balanced reaction. So looking at that, I've got a 1 in front of my SM, and I've got a 2 in front of my G. So I'm going to put a 2 in front of this G, and I'm going to put a 1 in front of my SM. Now cross multiplying, I get 2.5 moles of s'mores made. So I know that because this is positive and products are always positive, I can create from the 5 moles of graham crackers, I can create 2.5 moles of s'mores. So now adding this column up, I've got 0 plus 2.5, so I know total, my after, I'm going to have 2.5 moles. Now under this gram, I have 5 moles, and I used 5 moles. It's negative because it's on the reactant side. I know I'm going to have 0 moles left because 5 minus 5 is 0. All right, now here's another trick that I'm going to want to show you. You're not going to need to do mole conversions for every single one, but what you're going to need to do is start looking at your coefficients. If you notice that 1 mole of my coefficient for marshmallow is 1 and my s'mores coefficient is 1, and I've already previously calculated the change for this when the coefficient is 1, when I went from 2 grams to 1 s'more, I know without having to calculate that this is going to be negative because it's a reactant, and it's going to lose 2.5 moles of marshmallows. Why? Because it's a 1-to-1 ratio. So if I gain 2.5, I would lose 2.5. So excess minus 2.5 means I don't know how much I've got, but I know I've got extra, so I'm going to write excess. Now notice that the one in front of the chocolate is a 3. So I am going to need to change that one up. So we've got 2 moles of gram. Oops, sorry. We're not going to go with that. What you always do is you always use your C numbers. This is the only one that you can compare directly using your molar ratios. So what you're going to do is you've got 5 moles of gram. Okay, and I want to figure out this C. So for mole to moles right now, we're going to fill out this whole BCA chart. So that is going to be X moles of C. That is equal to 2 moles of gram. And where am I getting this 2 moles? Well, I'm looking at my coefficients. Once again, my coefficients, I've got 2 G's for every 3 C's. So I'm going to put 3 moles of C on the bottom. And when I cross multiply this, I get 7.5 moles of C. So what that means is that because it's a reactant, I am going to lose 7.5 moles of this guy. So excess minus 7.5 means that I have an excess left over. And this is my completed BCA chart. So when I look at my BCA chart, now I'm ready to answer all these questions. What is the answer for the above question, which was how many moles of s'mores? Well, that would be 2.5 moles. You're going to look at your after. Right, for every statement with moles of Teddy Grahams and moles of s'mores. So for every 2 moles of Teddy Grahams, 1 s'more can be made. And then for every statement for moles of marshmallows to moles of s'mores, for every 1 marshmallow, 1 s'more can be made. Okay, we're going to try another one, another BCA chart, and this one is actually just using real chemicals. So how many moles of hydrogen gas will be produced if 2.5 moles of calcium hydride react with an excess amount of water? So I'm going to fill in my B part, my B4 part, and I know that I have 2.5 moles of this. Okay, and I have an excess amount of water. And I know that my starting substances is 0 and 0 for my products always. So now what I need to do is I need to figure out how much am I going to lose. Well, I'm going to assume that all of that 2.5 moles reacts. So I'm going to lose 2.5 moles. That makes me have 0 moles of calcium hydride left. Well, looking at my coefficients, I see a 1, and do I see any other coefficients with a 1? Well, I see that calcium hydroxide is also a 1. So what I know is that because they are going to change at the same rate, I am going to lose 2.5 moles of calcium hydride, meaning I am going to gain 2.5 moles of calcium hydroxide. And so 0 plus 2.5 is 2.5 moles. Okay, and that's the only two that have the same coefficients at this moment. So now I'm going to need to start doing my math. So the first one that I'm going to try to figure out is my conversion of water. So I know that I'm losing 2.5. Remember, you are only going to be comparing any of those numbers in that C area. So I'm going to be losing 2.5 moles of calcium hydride, which I want to figure out how much does that mean my water would change. So that's going to be X moles of water. So I don't know that, but what I do know is looking at the balance reaction, what it states to me is that for every 2 moles of water, I need 1 mole of calcium hydride. So I'm going to put moles of calcium hydride on top because moles of calcium hydride is on the top on the other side. And then I'm going to put moles of water on the bottom because moles of water is on the bottom on the other side. Now I'm going to use the coefficients to put in for this ratio called the molar ratio. So I'm going to put 1 mole of calcium hydride for every 2 moles of water. Now I'm going to cross multiply, and what I end up getting is 5 moles of water. So I know that water will go down 5 moles. So this would be excess minus 5 moles would be an excess. What I also note is that because I've already done the work to go a conversion between something with a coefficient of a 1 and something with a coefficient of a 2, I know that the conversion between that this hydrogen will also not go down 5, but will go up 5 because it's a product, but because that has the same coefficient as the water, which was 2, I know that they will change the same rate. So that means 0 plus 5 is 5 moles. So how many moles of hydrogen gas would I produce? Well, that would be 5 moles of hydrogen gas. All right, doing this one down here, it says that I'm asking for how many moles of hydrochloric acid, so I'm asking basically about this guy, are needed to complete the reaction with 4 moles of lead. So my before is I know I have 4 moles of lead. What I know also is that I have an excess amount of hydrochloric acid. I don't know what that is, but I do know that I have that, and I know that I have 0 of my products. What I also know is that I'm going to assume that my change is I'm going to lose all of my lead and it's going to go to completion. So that means it is losing 4 moles, which means that I will end up with 4 minus 4, which means I will end up with 0 moles of lead. Now looking at my coefficients to easily fill in this BCA chart without having to do any math, what I do notice is that the guys that I just boxed in brown have all the same coefficient. So if I lost 4 moles here, what that means is that I'm going to gain the same amount over here. So I'm going to gain 4 moles of the lead 2 chloride, and I'm going to gain 4 moles of your hydrogen. So 0 plus 4 is 4 moles. So I'm going to gain 4 moles of both of my products. Why? Because they had the same coefficient as the lead that I'm losing. All right, so now I'm going to try to answer the question, which is about the moles of hydrochloric acid. So in order to do this, I'm going to need to set up a molar ratio using that change component. So I've got 4.0 moles of lead, and I want to figure out what would my change if I lost 4 moles of lead, what would my change of hydrochloric acid be? Okay, and I don't know that, but what I do know is that using that molar ratio, okay, by looking at that coefficient of 2 and 1, I know that there is 1 mole of lead, and notice I put it on the top. Why? Because moles of lead is on the top and the left, and I'm going to put 2 moles of HCl or hydrochloric acid on the bottom, right? Why? Because moles of hydrochloric acid is on the bottom left, and I got that 2 from looking at this balanced equation with that coefficient of a 2. So when I cross multiply that, I get 8.0 moles of HCl. So now I'm ready to fill in my BCA chart. So excess, I don't know how much I start with, but I know if I lost 4 moles of lead that I would also need to lose 8 moles of hydrochloric acid, which means that I would still have some sort of an excess amount. But the answer to the question is how many moles of hydrochloric acid did you need? You needed 8.0 moles of hydrochloric acid. All right, hopefully you kind of have a basic understanding of the BCA chart. Remember before, change, and after, and you will always use your molar ratios for when you are going to be using that change. So the C part always uses those molar ratios. That's where you'll use them in. All right, have a good evening.